one set of mother and child come in, and I observed them, and boy, they did great. They scored really high. They were hugging, and they really got along great, and I saw that. And then I have another mother come in right before lunch, and they didn't do quite so well. They didn't score quite as high. Then I have another mother and child come in after lunch, and they scored really well. And then I had one come in at 4 o'clock in the afternoon who didn't. Are these results based on whatever it is I'm manipulating in this study, which I haven't made up yet, so we don't know what that is, or are these results based on the time of day? Could it be that the first mother and child dyadic really, they had sleep and ate right before they come in, so the child was comfortable, they weren't cranky, they just woke up from their night's sleep, and therefore in a better mood, and therefore more likely to interact well. The ones right before lunch were hungry, hungry, sleepy, tired, grumpy, the children, because they want all those things. They need their nap, they need food, and therefore they didn't interact well. The ones after lunch, then again, were well napped and well fed. Could that play a role in your results? It really could. So when we talk about doing empirical research, what we want to put in our methods section is everything. Nothing is inconsequential. Everything you can think of that could play a role in why you're getting those results should be included. Because I should be able to read your methods section and reproduce it. So if I know that you looked at one mother-child interaction at 8 in the morning, when I do my study, I'm going to look at one at 8 in the morning. And you did one at 2 in the afternoon, I'm going to do it 2 in the afternoon. Think about for a minute, and I'm not looking for you to yell out answers. Nobody ever does in these things because I don't stop talking long enough. See, I can always tell when you're listening if people laugh at my jokes or not. If nobody laughs, I know I'm saying totally zoned out. You're not listening to me anymore at all. But now I lost my train of thought because I told a joke. I totally lost where I was. Okay, so we want to talk about repeating your results. Oh, okay, I know what it is. What can we do to standardize this same study? We can look at all the interactions at 8 in the morning. That's one way to do it. We can do many, many, many interactions over the times of the day and use that as an independent variable. Does the time of day make a difference on the interactions between schizophrenic moms and their children and the closeness of them? I mean, everything becomes almost an independent variable. Every decision you make throughout the research process. So you really want to think when you're going through, and I'm a big list maker. I can go in my office, and my office is really neat, but there's 10 different pads of paper like this with lists on it of things that I'm doing. So I do recommend, and believe me, I've worked with enough doc students now to have them come back to me and say, Jay, thank you so much, this really worked. And one of the things is I recommend that you start keeping lists as you go through the process, because when you sit down to write out those weaknesses or those methods, all the things that you thought about that seemed so evident at the moment, all of a sudden, you can't remember what they were. So it's really a good practice while you're going through this process to keep yourself a list and write down. I usually, do one for weaknesses, one for things that could be independent variables or confounding variables, and just keep a running list. It makes it super easy when you get to the chapter that you need to write that up, because you have them all listed. You have something reminding you of the things that happened during the process. So I know that usually about 45 minutes of me talking nonstop is enough for anybody. So we are getting near the end. You'll be happy to hear. But I do like to try to give you a couple little tidbits of helping you through the dissertation process. One of the things I will say to you is make sure that when you pick, if you haven't yet, your committee members, that they work well together. I've seen many students stumble because they chose committee members from all over the place. And while some people work really well together, others have totally opposing viewpoints, right? There is, your dissertation chair is a factor in this process. Whether you want to accept that or not, it's the truth. Whoever is mentoring you through the process has a huge impact on how well you'll do and how much you'll learn. I mean, this isn't just about writing the dissertation and pumping it out so you can get the piece of paper and get a pay bump or get a new job. It's really about coming out with some skill set that you didn't have before. And that being said, I hope that one of the things that you come out with is being a critical consumer of the research. And I hope that's what here today, that you get a little bit of that. And you start to, when you read things and when you develop your own methodology plans, that you start to see things a little bit differently. that it isn't just I need 15 articles because that's the marker that my professor said I needed in my paper. It's that you know that there's a point where you can see that this is relevant to my topic or this isn't relevant to my topic. And I'll tell you, I get more email questions as, not as your professor, but as your librarian, that says, well, there's nothing on my topic. Or I get students, my master's students especially, that write, no research has been done in this area. Well, that's their lit review, no. No, you can't get away with that. You're getting an advanced, you're getting a graduate degree. It's up to you to make those connections. The best dissertation topics in the world have no articles written on them. They haven't been done yet. If you go and your exact research study has had 60 zillion articles written on it, it's pretty well explored. I'm not saying you can't do it, but it's pretty well explored already. The best dissertation topics have nothing written because nobody's thought up that question yet. So it's going to be up to you to pull together the different areas of the literature that's out there and make it meaningful. So if you want to study some new angle on something, what you need to do is what's related to it, and you almost do mini lit reviews linking them together within the literature review portion of your dissertation. So I always like to leave people with that because that's my most asked reference question, and I answer like 290 reference questions a semester through email. So hopefully at least the 39 or so of you that are here won't ask me that question because you know the answer is going to be, it will be up to you to find the topics that are peripheral and link them together in a meaningful way. If in fact you start searching for your literature and you're not finding anything, good for you. It means you're on the right track doing some research that's cutting edge and hasn't been done before. So, I know that's enough of listening to me. Does anybody have any questions? And my email's up here. I am your librarian as well as faculty member here. Well, I'm faculty librarian, but I am both. I'm a teacher and a librarian, so if you need help when you're writing, you're more than welcome to email me. I'll take appointments in my office to guide you through anything. But does anybody have any questions of anything I said that was really confusing? I do workshops on SPSS, and I'm going to start, I just got a grant to offer webinars, so I'll be able to do a lot more of these through the computer where you can all sit in your offices. And so I recommend that if there's topics like that and you think that it might be something I can do, email it to me, email it to Nadine, email it to the DSC. We're all really, really eager to try to get these in place so that whatever you need is in place for you. Right now I'm doing APA style, SPSS, stats refresher workshop, and then I'm doing some more advanced stats stuff as well. But I'll be doing, SPSS really works best in the lab because of the hands-on, but I will be doing them, and if there's a need, like I don't know your schedule well enough because I'm relatively new here, so I don't know when the push is for you to be learning that. I taught it in my critical analysis 2 class because I feel it's a skill that everybody should have touched it. Yeah, no matter what you're doing, you should have your hands on it, because it's so valuable when you're in your everyday job. Even if you plan on going into something new, to have that skill, and I can't tell you how much it's helped me with every job interview I've ever done. And I'm interviewing right now for a new social work librarian that will be an entry-level position, and that person must know SPSS. It's just a really valuable skill. So I will, if people email me, you see me set up one of these things and the time is just horrible, email me and say, Jay, that's right in the middle of our classroom, or that's right in the middle that we're doing this or that, because I don't know unless the students communicate with me. And I'm real open. I answer my email on my iPhone, so I get email really quickly. If you call and leave me a message, by the way, you won't hear from me for weeks and weeks, because I always forget to pick up my phone messages. So if you need to get me, email me, because I haven't looked at my phone messages in probably a week, but my email, I'll turn it on as I walk to my car and answer email.
Is there a website for SPSS?
It's a software that you actually have to pay for.
Oh.
So, there's many. My favorite is the University of Texas has excellent tutorials if you just want to go on and do it yourself. I use a lot of their materials when I teach because the way it's laid out is really, really easy to understand and easy to follow through on your own. But we are going to make an effort in the whole School of Education, not just the DOS program, to make sure that that's available to anybody who would like it. So I'm going to start with the web. I got the grant a month ago. I just got the money, how's that, in the software to do my own webinar. So we just did the first one. I don't know if anybody thought it was on testing and measurement last week, because People didn't see the invitation back, and see, I'm not quite sure how to get to you all. I did one on Facebook. Well, I email them. I try to get them to listserv, is what I try to do. But, you know, are you all familiar with my list guide? Some of you saying yes, some of you saying no. Just so the ones that say no know what I'm talking about, because it's really hard to get through this program, in my opinion, without this. I wouldn't want to have to do it. So you go to the library's homepage here, and you go under Research Guides, scroll down under Most Popular Guides and choose Education. You have a research guide here that's everything that will be relevant to you while you go through this program. Here is your funding opportunities if you're looking for some money to pay for the measurement tools that you'll use for your dissertation. The library doesn't purchase measurement tools. It breaks copyright. So if you say you're going to use the MMPI, you better have the money to pay for the MMPI for your students. We cannot purchase measurement tools. So I have a whole section on testing and measurements that will explain that to you, tell you how to find free tools, how to find how much tool instruments cost, a whole APA style page with tutorials and PowerPoints, great handouts for cheat sheets. DocScribes is my favorite, 22-page cheat sheet, everything you ever needed to know about APA style. We have, I'm starting now to develop ones for specific focuses within the School of Education, but your Find Journal Articles page, if you're not using Google Scholar to find your journal articles, boy, you're wasting a lot of time. Google Scholar links with USC's databases. We have over 1,000. There's nowhere else that you can look at all 1,000 databases except for using a product like Scholar. On top of that, you're doc students. You're not undergrads. We're not saying find 5 research articles on psychology. You really are responsible for finding everything on your topic. Therefore, it doesn't matter what USC has or doesn't have. You all hopefully know about IDD. Those of you who've seen me lecture all know about that. We have instant document delivery. It's free here at USC. The USC libraries will purchase, digitize, and email you any article in the world for free. Never seen an institution that does this for free for students. So sign up for it if you haven't yet. That stuff is all right on my homepage under Quick Links. You can go to the ILLiad IDD service. You do need to sign up before you can start requesting articles. You just click on go to first-time users. You fill out the form. They'll verify you are who you say you are. The reason they do this is graduate students get more services there than undergraduate students. We do the instant document delivery for undergrads, but if we own the article physically in the library, we make the undergrads come and copy it themselves. If we own it and you're a graduate student, you can request it through the service. They'll get a student to digitize it and email it to them. By the way, second most referenced question I'm asked is, Dave, can you get this article for me? No, I can't. I don't pull articles. I don't even live in the libraries. I have an office over in the social work building, and we don't have somebody that can just go pull a bunch of articles for you. However, this department pays students to do this service, that you have to go through that service. I can't even request them for you. But this is your LibGuide, so if you don't have this bookmark, make sure you do it. You need to figure out how to set up Scholar if all of a sudden you're going, I didn't know about the Scholar stuff. I have a tutorial right here. I mean, everything that you want is pretty interactive, and it's set up so that, I really set this stuff up so that you can find what you need and get through your program with minimal stress. We don't want you to come out of here with so much stress that you can't take the job that you went to school to do. So, this is really, it's really responsive. I work on these things all the time. If there's something on there you hate, you love, you're not telling me if you love it, but if you hate it, tell me, because I'll reattach it and take it off. If there's something missing that you know of a great resource that your colleagues could use, email me the link. I'll put it up here. These things are super easy, so I work on them all the time. I work on them in my spare time. But this really, if you're struggling at all with library resources, APA style, all that stuff is on here. I will put the slides from today on, what do we do, stats today? On the Find Statistics page, so I'll just make a little box on here tomorrow morning and put these slides up so they'll be there for you. Any other questions? No? Right on time. Well, thanks for coming. Have a nice evening. I hope that the title today is not deceiving. Let me tell you a little bit about this workshop and how it came to be, so you know where I'm coming from. The first thing is I'm not here to teach you any math. So if you were hoping to write down a bunch of long math equations, I'll give you the reprieve, you can walk out now because math is not my favorite thing. I am a social science research methodologist though. So what I hope that this session does, and what I really developed it for, was people who are coming to back to school and really aren't used to the language of research methods anymore. So we're going to talk about the concepts, talk about the ideas, the terms you're going to commonly see used. If you want the formula for standard deviation, put it in Google. You'll find a million of them. Now, they'll all be the same one, but you'll find a million places you can get those equations. So tonight's really not about teaching you the math, so I hope that my title isn't confusing. This workshop was really developed for my master's students in the social work program because we accept students from any background in that program. And what we found was many students were dropping out when they got to the research methods course. And we felt that if we were accepting students from any background, or I felt and worked with the dean on this, that then we should give them the skills to be able to succeed in our program. And what we were finding is if you came in with an English degree, you got to social science research, you got to research methods and social work, and you were dropping out of the program because you didn't understand. It was like walking in, and as I was speaking French, for those who don't speak French. And that's really what happens to people in research methods. The concepts aren't really that hard. The equations, if you like math, aren't very difficult. But what happens is if you're away from the language for a long time, it gets scary. So that's what we're going to go over tonight, is just talk through some of the concepts. You'll see I'm going to make up little stories about research as we go along, and I do make these up. So there's no mistake when I'm stuttering and stop for a minute and think. It's because I just like to make up research projects as I go instead of having one that I always go back to some canned project. So let's talk a little bit about our agenda tonight. We're going to talk about statistics vocabulary, research vocabulary, different types of statistics and analytical techniques, and then a little bit of reporting out on statistics. And I'm going to talk a little bit too, I added some slides in today about reliability and validity. Because I had a student this morning come in my office, and I'm teaching research methods right now, and he said, I never read an article the same way I used to since being in your class. And I said, that's awesome, why? And they said, because I used to read the abstract and the conclusion of articles, and then I cite it. Well, I want to make sure that when you leave here today, that nobody does that in their dissertations. We really want you to be able to evaluate the research. I don't think I have any students in here from my course, but I taught the quantitative part of critical analysis too this semester. And it's a good thing that they're not here because they already got this lecture. So what I had them do is I said, everybody bring next week your best article for your dissertation. The article that you like the best, that you feel you're citing the best or relying on the most. And pull out the independent and dependent variables and tell me a little bit about their methods they use, the analytical techniques, any scales, measurement tools that they use. And so my students all came back. There was not one article. These were all published in peer-reviewed journals that we couldn't find an error in the methodology. Not one. That didn't have either, and when I say an error in the methodology, that could be as little as having obvious weaknesses that they didn't report in their methods. But the idea here, and what I want you to get from this, is that when we talk about research and when we think about research, it's not just this is what the abstract says and this is their conclusions, and therefore I can move on that and cite this article. You're at dissertation level, so it's very important that you're doing evaluation of the method section when you're reading your articles. I'm not saying that they're no good, throw them away when you find errors, but however, it can really strengthen your argument, whether you in either direction. You may be reading an article and you don't really agree with what their results say. And then when you evaluate their research method section or their scales and measurement tools, if they haven't used something correctly, it's very easy to then point at that error and say, therefore, although Jones and Smith found X, Y, Z, there were these problems in their methods section. Therefore, there's questionable results. Or, on the other side, if you find that they use things correctly, their methods were really good, you can point at that as well to support your argument. But I really hope, those of you who do know me know my background, my master's is in librarianship, so I'm really, really strongly in support of information literacy skills. And that is an information literacy skill, not just to find the information and use it, but the evaluation that comes in the middle. So everything I do on this campus, kind of that's interwoven a little bit. So let's first talk about the definition of statistics. Statistics are just the methods used to summarize, analyze, or make inferences from data. This is important when you think about the word inferences, because as we go on, you'll learn that a lot of what you're reading is not inferential statistics at all. It's only descriptive. And I hope that you leave here today knowing the difference. I will put these PowerPoints up on my LibGuide tomorrow morning. By the way, it'll be on the Science Statistics page of my LibGuide, and I'm going to send them over to the EdD program office, so they'll be available to you there as well. Statistics vocab first. So let's talk a little bit about Maker's central tendency. See, if you've been out of school for a while, it's like speaking French, right? We all know what the mean is. In statistics, the mean is simply the average score. The median is the point in distribution above which 50% of the scores lie above and 50% of the scores lie below. So it's really just the middle point of the range of scores that we came up with. And then the mode is the most frequently occurring score or value in your data set. Now, when you read research articles, you often won't see people point to many of the terms that we'll talk about tonight. However, for dissertation research, you'll be required to report on these. So it's a little bit different. When you read an article, don't think your dissertation is going to look like a journal article that you read, because it is not. We have many more requirements for the dissertation process than we do, the publishers do in the peer review process. So when we talk about things like standard deviation, we expect to see that in a quantitative dissertation. But in a research article, generally when I'm writing something for publication, I don't refer to standard deviations. I have them because I ran the analytical techniques, but you don't report them. So some of the things we'll talk about tonight, don't use the models, because the things we'll talk about tonight are things that will be required of you in your dissertation, especially if you're a quant person. Now, if you're doing all qual work, you probably didn't show up tonight, let's face it. Anybody who's doing a strictly qualitative probably didn't come to something entitled Statistics Refresher. But if you did, good for you, because I think it's important that you leave. If you're leaving with USC with a doctorate, I think it's important that you leave with some quant and qual skills, to be honest with you, even though I'm a quant person myself. So let's move on with some more vocabulary. The next thing is standard deviation, which I've mentioned, and it's really the most widely used indicator of dispersion. And it's, in a nutshell, it's based on the deviation of each score from the mean. I'm sure everybody remembers the big bell curve. I actually, when I give handouts, and I'm always on the fence about giving handouts, because when people don't listen, they write. I don't want you writing it down. Just listen. You can go back to the slides later. They're all there for you. You can print out handouts from this. But I always go back and forth on the bell curve. I take it out and put it in this lecture and take it out and put it in, because I can just never decide whether people really need to see it or not. But that's really, if you remember the bell curve from undergraduate, the standard deviation is how many scores away from the middle there is. There's generally 3 in a normal distribution, 3 standard deviations away from the middle. And what it does is it provides us with a measure of how spread out those scores are. And the reason this is important in statistics especially is that if we have a really spread out scores and it's not normally distributed, we can't assume that some of our analytical techniques will work. Therefore, most of the things that we do in SPSS, when we pull down and say we're going to do a chi-square, we're going to do a regression analysis, when we choose those analytical techniques, it isn't just based on what's fun and looks good at the moment. It really is based on what you know about your data. And one of the things the standard deviation will tell us is it normally distributed? Most of the standard tests that we'll do in SPSS are based on normal distribution. So if you know you have a data set with some real heavy outliers, you need to look a little bit more into the choices of your analytical techniques. For example, I want to study college freshmen. I want to look at freshmen and I want to see if my information literacy program is going to help them with repayment. They're going to stay in school and get their bachelor's degree. So I'm going to start surveying and looking at all the freshmen coming through USC. And I'm going to have an experimental group that I'm going to give them information literacy instruction, and I'm going to have a control group that are not going to get any information literacy instruction. Well, it just so happens that I start this on a year that USC decided to recruit within the senior citizens community for college freshmen. So my class has an abnormal population of people over the age of 65 for college freshmen. I can look at that data and I know that my data is not normally distributed for the population that I'm interested in. So right away I know I have to alter the analytical techniques that I choose. I wouldn't choose a chi-square, because I know that that's based on the normal distribution. So that's why standard deviation is important, is it tells us whether or not the people we're looking at, our sample, is distributed normally or not, which then allows us to pick what analytical techniques that we'll use. If you're feeling a little lost and like I'm speaking French, don't worry. It gets less and less confusing as I go on. Okay, so we talked about the normal curve. Why is it called normal? Because so many things in life are distributed in the shape of that bell curve. IQ, strength, height, weight, musical ability, resistance to disease, and so on. But not everything's normally distributed, but most are. So, like my example of if we were marketing to senior citizens coming back to school and getting a degree, you can see that there are some things that would not be normally distributed then. So what is the definition of research? Research is really a systematic process of collecting and logically analyzing information for some purpose. For most of our purposes is we want to make inferences about it. We want to take that data we collect and be able to say something about the population out there that we're interested in. Whether it's a program, whether it's an intervention, whatever you're studying, whether it's the accreditation processes, all those things, we want to make some inferences and say, hey, this is the better way to build the mousetrap. This is the way we should be doing it. We don't want to just talk about this is what it looks like, okay? And that's really the difference when we talk about the difference between descriptive and inferential statistics, which we'll get to in a minute. So let's now move on from that to research vocabulary and talk a little bit about data first. There's 4 types of data: empirical, observational, archival, and anecdotal. Empirical data is what I just described. I'm going to have some intervention, in my case information literacy instruction. I'm going to give it to one group but not another group, and then I'm going to see the outcomes. That's what we call an empirical design. Not to be confused when people say empirical research articles. There's a lot of crossover between some of the terms used in information literacy and some of the terms used in research, and they're really being used as that they're interchangeable, and they're not. Empiricalism is a way to design a study. It's a methodological design. When people say an empirical research article, often people interpret that as a peer-reviewed article. 2 different things. Empirical is their methodological design. They had a control group, they had an experimental group. They gave one group a drug, the other group didn't get the drug. They gave one group an instructional session, the other group didn't get that instructional session. That's empirical design. When people say empirical research articles, they usually mean a peer-reviewed research article. Peer-reviewed articles can be empirical, but they can also not be empirical. So understand the word empirical really means the type of methodological design that they're using. The next type of data is observational, and in social work they do this a lot. They want to see how schizophrenic mothers are interacting with their children. So it's really hard to measure that if you rely on the mother's self-report. So what they do is they often set up some sort of room where they can watch and they can code what's going on. Okay, the mother hugs the child, the mother kissed the child, the mother, puts the child away, or they're coding it by observing. There are some issues with observational data, but there are issues with all data, even empirical, let me tell you. So don't think that if people get to be what we call research snobs and say, only quantitative is best, you have to do everything empirical quantitative. We're social scientists in the field of education and social work, and the truth is there is no perfect research environment. I can't go out and give one group of mothers schizophrenia and another group of mothers I'm not giving it to. And that's the true empirical design. So when you think about it that way, all data is going to have some weaknesses. The key is learning what those weaknesses are and how to use them and how to report out on them effectively and to support whatever your design, your hypothesis is. So observational data, somebody watches, one of the big weaknesses we associate with this is who's watching. If I'm watching, would I code it the same if you're watching, or if somebody else was watching? That's where we get difficulty, is it becomes through the lens of the observer whenever we're talking about observational data. So that's something that we always want to be aware of. Is it perfect? No, but we're social scientists. Not perfect world for research for us. We do the best we can. Many times observational is the best we can, which would be the case if I was interested in schizophrenic mothers interacting with their children, because I really have no other way to get at that data. What I'd like to do is set up some coding system where any one of you could walk in and I could hand you my coding and you would score an interaction the same as I would, right? That's the best we can do with observational data. But just remember, it is always going through the lens of the observer. And we all bring biases to the table whether we're aware of them or not. The best researchers are aware of their biases. You start to learn what they are, and you start in reporting them. The real key is really, really good to me. Social science research has a big fat weakness section and a big fat bias section in it, because you're showing me that you knew what the weaknesses and biases were. If you don't have that section, I know what they are because I'm a social science researcher, but I wonder if the people writing the dissertation know. And that to me is much weaker than any weakness you'll ever report. So what I suggest you do when you're writing your dissertation, anytime you think of anything that might be a threat to your validity, reliability, to your data at all, keep a list. Just that's what I did. I just kept an ongoing list of things, and then you have that section pre-built for you when you get to the part where you need to talk about weaknesses and biases. Don't feel like, oh, my study's no good because I have this big section. What it's showing is that you're a good researcher because you know what the weaknesses are associated with whatever methodology, with whatever data that you're collecting. Archival data. In education, we use this a lot. IPEDS is my favorite. I don't know if you all know about IPEDS, but I love IPEDS. It's the Integrated Post-Secondary Educational Data Set, and it lives behind the NCES, which is the National Center for Education Statistics. It's a large data set. The NCES, by the way, is for K-12, and IPEDS is for post-secondary education. So these are huge data sets that the government, the Department of Education collects every year, and you can go in and data mine. So if you know how to use SPSS, you can actually import data right out of these data sets into SPSS and code it and run analytics on it. And I know many people who have done their dissertation just on archival data like this. They actually didn't even go out and collect anything. And then there's anecdotal data. Well, I think that schizophrenic mothers that are in a warmer room interact better with their children because that's kind of what I've seen happening. So I'm going to make all the rooms warmer. That's anecdotal data. I have no proof. That's just something. Many times, what becomes empirical data is because it was anecdotal data in the first place. It's because one of us researchers saw something and suspected it and then wrote a research study to try to prove it correct. And so anecdotal data is important. And in social science, it's very important because a lot of times we can't do the interventions that we want to do. So sometimes we have to move forward with anecdotal data. So if you see some patterns emerging from the observations that you've done in your dissertation work, don't just throw them aside and say, well, I can't talk about that because it's not empirical or wasn't in my research questions, those type of things. Anecdotal data would be reported in your discussion section of your paper. So you do want to include that. If you see things that are strong anecdotal data, and you report them as such. You don't say that I found proof. You don't say that anything you're going to do. But what you do say is there is, anecdotal data that suggests that X, Y, Z happened in my study, therefore more research in this area is warranted. You would say something like that. This was really, really heartbreaking to me. When I taught critical analysis too earlier this semester, my students all got this wrong. I could not believe, and now I'm teaching Research Methods 562, and my students all got this wrong. So make sure you understand the difference between a population and the sample. If I'm interested in college freshmen across the United States and whether information literacy will help them attain their degrees or not, that's my population. My sample is the set of participants that I looked at. So your population is who do you want to generalize your results to? I just graded a paper right before I come in, and it said, my population sample is, I thought, no, your population and your sample are two different things. But I was really, really shocked that on an assignment that I had with my doc level students that this question stumped people, and I think that just we don't think it through clearly, but just associate participants with samples. Your participants are your sample. The population is the more people at large. Now, I talked about evaluation a little bit, and I said how important that is to me. Boy, I'm having a hard time not wandering around when I talk. I have to move my hands more. It's a good thing I'm Italian. One of the things that that you have to think about for evaluation is when you pull your sample, is what does that mean for your population? So if I was to only look at students at USC, and I was interested in college freshmen, what does that mean? What are some of my weaknesses? I have to think through all this. Does it make my results unwarranted and that I shouldn't use them? No. We do the best we can, and it's a convenience sample. I'm at USC, so are the freshmen, so I'm going to sample them. However, when I write up my results, I need to talk about what may be different from my sample than the general population. Let me give you a few just off the top of my head. We're in Southern California. Maybe these students like warm weather, or maybe they're all surfers, or maybe they are from a different SES, and that's why they're coming to a private university on the West Coast instead of a public one. Maybe, well, I can tell you one thing. You write anything in your sample comes from California, you have to talk about the fact that we're a border state. No way around it. It makes our population different than some university in the Northeast. It just does. There are many, many things that you have to take into account. Really good researchers, really people with above average information literacy skills, this is the way you approach not only your research, but everything you read for your dissertation. Start to think about, what does that sample mean compared to your population? How does that sample differ? This is something that many people don't report on. And if in fact you're reading articles and they're saying the exact opposite of what you want, and they have obvious differences between their sample and the population, it's a great way to attack their data and say, yeah, this is out there. You can't just ignore literature. If there's a bunch of stuff saying one thing out there in the literature and you're saying something else, you can't just ignore it and not include it. I sit on people's dissertation committees. Believe me, we look, okay? We'll find it, and we'll say, hey, you've missed this big body of the literature, you need to explain why you don't feel, why you feel your questions or your hypotheses are better. So think about the relationship between the sample and the population, both in your research and when you're reading things. More vocabulary. Like I said, most of this is just vocabulary and telling you stories so that you have hopefully a little bit better understanding when you leave here today. There are 6 types of sampling plans. Each one of them has their own weaknesses and strengths attached to them. I will not go into great detail because if I did, we'd be here for 6 hours, but let's just go through them quickly. Random, best of the best. That means that everybody in the population has an equal opportunity to be in your sample. I took all the college freshmen in the United States, I put their names into SPSS and used a random number generator, and they assigned me the 250 that I said I want to sample. Every person in my population had the equal chance of being in my stratified. So I want to look at college freshmen, and I know I can't do a true random sample, so what I'm going to do is I'm going to pull some from here in California, and some from the Northeast, and some from the East Coast, and some from the South. I'm going to try to stratify it to make it look as much like the population as I can. Volunteers. Volunteers is very common. You put up a sign in the psychology department and say, all freshmen, come be in my research study. Generally, we offer some incentives here. You have to think about the weaknesses associated with getting incentives. Let's say the psychology department said, we'll give them 5 extra credit points. What does that mean for the people who came forward? It probably means that either A, they're the most conscientious students in the psychology department, and they will do anything they can for extra points because they all want A's, or B, they're struggling and they need the extra points. The average student won't show up. And this was really interesting. I was just reading this on a test that we're making for the research methods course, and it was saying that they put signs up because they were interested in whether or not the community cared about condos being built. So they put signs up saying, volunteer for we want to know your opinions on the condo project. Well, when you think through that a little bit, what are the issues associated with it? The people who really are in the middle of the road on the topic are never going to call you. There's a phone number. The only people who call are builders who are involved in the condo project and want to say, yeah, we think this is awesome, or the people that are getting kicked out of their low-rent apartments because they're building condos. They have a vested interest when you're asking for volunteers. Still, we use it all the time in social science, but those are the weaknesses attached. Convenient samples, most of what we do is convenient. I'm using USC because I'm here at USC and it's convenient for me. Purposeful sample would be more along the lines of what I said earlier. There's some direct purpose. I want to look at schizophrenic mothers and their interactions with their children, so therefore I need to go out and pick purposefully. I need to find a sample from somewhere that's going to give me schizophrenic mothers. I just can't go into the general population and wander around until I find enough schizophrenic mothers to be in my sample. So there's some purpose behind how I did it. And then there's systematic sampling, which is often called matching. And what that means is, for every schizophrenic mother that I've got in my sample, I'm going to match somebody who has the same ethnicity, age, education level, whatever I can. I want two people to compare that can be really, really similar. So it's a systematic matching process. And we often do this in education because there are variables that we can't account for any other way that will become confounding variables. So what we often do is we have this set of children that we know we're going to look at, and then we can go out into the larger school, larger district, whatever, and match other children that look like them demographically, that maybe don't have the same diagnosis that they have, or the same issues, whatever it is that we're purposely looking for. So we match them all except for whatever our independent variable is, and that way we have good comparison groups. It controls for age, ethnicity, all those things that could confound our data. Hypotheses is a prediction about the relationship between variables. This is not your research question. This is generally what you're saying. I believe information literacy instruction will improve retention for freshmen in the United States. Right? Don't say America, by the way. I learned that lesson. The best thing to leave here with today is that when you're writing, always use the United States, because if you're in Europe and other countries and delivering your research, which I've done, and you say America, they will nail you to the wall, because it happened to me, believe me. Always say United States. America means the larger Americas, including Canada and Mexico and Central America and South America, and so when your data is really done from the United States, make sure you're clear and use the United States. Take it from me. You don't want to be in Ireland and have someone do that to you. The null hypothesis is a prediction of no relationship. So I don't think that my information literacy instruction really is going to have an impact on college freshmen and their retention. Or directional. I predict a specific relationship, more information literacy instruction, more graduation rate, higher graduation rates, right? So variables, you guys have heard me refer to these a lot already, but to be very, very clear, independent and dependent variables, you need a firm understanding of this to do a dissertation. Your independent variable is what you're manipulating. It's the intervention, it's the course, it's the instruction. The dependent variable is what you expect to see change. In the example that I'm using today, it would be the retention rate, right? So dependent is what is going to change. The independent is the intervention, the course, whatever it is you're manipulating to try to see changes in the results. This is a big one too. I had all my students come back to me in critical analysis and say, I didn't realize how many of my articles I'm relying on are just descriptive statistics. Descriptive statistics do exactly what they say they're going to do. They describe what's going on in the sample that you looked at. So that's all the things like, there's 40% retention, there's the ethnicity, gender breakup, there's age range, all those things. That's descriptive statistics. Really surprisingly and deceptively, many of the research articles we read are only descriptive statistics. But we never realize it because we read that abstract and we read the conclusion and we cite it from there. When you really start looking at the methods and the results sections of papers, you'll see much of what's published is really just descriptive. It's describing the population. Not that that's bad. I'm not saying that you can't cite that, but you need to understand the difference. Inferential statistics is what is actually analytical techniques that allow us to make inferences about the population or sample. Then I can say, well, I'm showing this direct correlation between my information literacy instruction and the graduation rate, and therefore I can infer, because of the way I design my study, the analytical techniques I use, that information literacy will also increase graduation rates in making an inference there. Correlational shows the relationship between variables. Everything you do will be correlational. Don't kid yourself. Don't claim causation in your dissertation unless you're doing a true empirical design. My guess is most of you are not. Even with what I just said, I don't really know many people that do research that can claim causation. If you're doing advanced regression analysis, which I actually did, and I like regression analysis, you can talk about cause, but it's a set of variables. It's very different from what we normally think. You would never say information literacy causes higher rates of graduation. I could never say that. What I could say with regression analysis is that I built a model, and through ethnicity, age, information literacy, location, through a group of variables, I can show some portion of a cause for things to change statistically significantly in the rate of graduation. And I know that's confusing. Most of you will not be doing advanced regression analysis, so don't sweat it, don't worry. If you are thinking you're going to claim causation, make sure you look at your analytical techniques, because very few analytical techniques can do this. My guess is anybody in the room that plans on saying any kind of cause, you will be using regression analysis. Everything else is just correlation. The chi-square, all the data, the t-tests, ANOVAs, those are all correlational studies. All you can say is that your variables are related to each other and what direction those relationships are. That's most data. When you see somebody claim cause, right away I go to their methods and see what they did analytically, because there are very few research studies that we can claim cause in social science. Well, I guess I already talked through this slide because it's correlation and cause. So most importantly, like I said, if you're not using regression, don't claim causation. Most of what we do is correlational, and that's the standard in social science research. So how do we evaluate things in measurement and observation? The first thing is are we measuring what we intend to measure? And then, whether the same measurement over and over and over again, you read my study, you go do it, you go do it, you go do it, would we all get the same results? These two concepts are reliability and validity. So first we'll talk about reliability. Reliability is concerned with questions of stability and consistency. Does the same measurement tool yield stable and consistent results when repeated over time? So we think about measurement processes in other contexts, in construction and woodworking. I like to use this example. So if I have a piece of wood, and I'm going to measure it, and it says it's 2.5 feet long, I can have any one of you take my tape measure and measure, and it's still going to say 2.5 feet. That's a reliable measure. However, if I just made up and looked at it and said, oh, I think this is an inch, and this is an inch, and this is an inch, and so I'm going to say it's 2.5 feet. If I went to another piece of wood, what are the chances are that I would come up with the same by going this. Very slim, not reliable measurement. So think of a tape measure as a reliable tool. Every time anybody uses it, it's going to give you the same result. There's 3 different types of reliability: the test-retest reliability, the inter-item reliability, and inter-observer reliability. Measures that are high in reliability scores should have all 3 of these things. So you want it to get the same results repeatedly. You want the items on the measurement tool to be related to each other. Therefore, on a tape measure, 1 inch is 1 inch is 1 inch, no matter where you pick on that tape measure to look at it. It's not 1 inch over here, and then it's called an inch here, but it's a little wider. There's some standardization between the items. In social science surveys, what we often see is that we want to see that the items on a scale are related to concepts or constructs related to whatever we're measuring. Actually, I think that's on another slide, so I won't talk through that one. But we want there to be some inter-item reliability, that the questions have some meaningfulness to each other. And then inter-observer. If you use the tape measure, and I use the tape measure, and you use the tape measure, we're all going to see the same 2.5 feet. This is one of the problems with observational research that we spoke of earlier, is that sometimes if we're just sitting in a room talking about people interacting with their children, we're going to have problems because we're going to interpret that differently. And that's that inter-observer reliability that we want to always look for. Next up is validity. And validity refers to the extent that we are measuring what we hope to measure and what we think to measure. So continuing with the example of measuring a piece of wood, a tape measure has been created with accurate spacing for inches, feet, etc. should yield valid results as well. So it's not only reliable over and over again, but it's also valid. Measuring the piece of wood with a good tape measure should produce the correct measurement of the wood's length that will be valid every time and reliable every time. So there's a couple different ways to look at validity. First, we talk about internal validity, and that has to do with how well a study was run. That really has to do with, are you measuring what you say you're measuring? I had a research proposal I was reading this morning, and they were looking at, I can't even remember now, but whatever they were looking at, it was, they had a measurement tool. Oh, they were looking at success in some social welfare program based on another social welfare program. So if they did A program, then they would do better in program B for life skills. But then they came up with some measurement tool out of Burroughs that had nothing to do with A or B, in my opinion, that had poor internal validity. I don't believe that they were measuring what they said they were going to measure. Now, they were going to use a life skills scale, so what they should have done is their research questions should say that program A would increase life skills. Then they would have internal validity. They would be measuring what they say. But you don't say A is going to increase participation in B and not measure participation in B. You need to be measuring what you say you're measuring to have internal validity. External validity is really, to me, the easiest concept. This is what we spoke of earlier in the sampling issues, is that how well does it represent the extent to which a study's results can be generalized or applied to other people in the study. So how well does our sample fit with our population? That's really what external validity is all about. And that's where, when you talk about any weaknesses due to your sampling, that's where the threat comes in. It's a threat to your external validity when you have to make concessions in your sampling, which we often do. So when you talk about the fact that we only looked at freshmen at private, prestigious university in Southern California, that limits our external validity. I can't speak really and have a lot of confidence in speaking to a public school in the Northeast. I don't know if my results would generalize well to them because there are some inherent differences. So that's internal and external validity. I'm going backwards now. Okay, so now let's get into analytical techniques. There are parametric and non-parametric statistics. The mean, the standard deviation, t-test, product moment correlation belong to a category called parametric stats. That's because it's assumed the data used to compute them have certain parameters and meet certain conditions. Those parameters and conditions are generally that they're normally distributed, that we talked about earlier. Non-parametric statistics, you can do many of the same things, but they're regarded as less powerful, and they're not to be looked down on, though, because when conditions call for them, non-normal distribution of our data, we have to rely on them. You can't run the general analytics that you would normally use if your sample isn't normally distributed. So one of the most useful, the non-parametric stats is the chi-square. We use this a lot when when our data consists of people distributed across categories, and we want to know whether the distribution is different from what we would expect by chance. Statistical significance. This is what we're all looking for, right? We want to say that you found some statistically significant difference in whatever it is you're manipulating, your independent variable and dependent variable scores. So, we don't have scores, we don't have means, we just have numbers or frequencies when you're doing the chi-square. Analytical techniques are generally the statistical procedures used to analyze data. This is when we talk about chi-square, t-test, regression analysis, ANOVA, MANOVA. There's another one now they just added. Does anybody know it? It's ANOVA with one variable, MANOVA now with multiple variables. Now there's another one. It's like there's a zillion independent variables in it. And I just read it the other day. I was like, what the heck is this? But it has the ANOVA after it, but it has the first letter is different, like a GANOVA or something that I guess is a new one. But basically, when we talk about analytical techniques, this is what you're choosing when you pull down an SPSS to work with your data. If you've used SPSS yet or you're familiar with it, it's a statistical package for the social sciences. It's what anybody using quant data here will probably use, and even those of you using qualitative data, generally people use it for their demographics, their upfront stats, just to talk about frequencies and what their sample looks like. So, empirical research, what is it? It's based on the Groot's empirical cycle, and it's based on observation, induction, deduction, testing, and evaluation. And you can read through the cycle, the collection and organization of empirical facts. We form the hypotheses. In many cases, depending on who your dissertation chairs are, you will have to talk about your null hypotheses, right? That really is dependent on who's on your committee and your chair. But I know in critical analysis too, they make us go through this exercise of what would the null hypothesis be based on your hypothesis. Null hypothesis always means no change. So my hypothesis is information literacy instruction increases graduation. The null hypothesis would be information literacy instruction has no effect on graduation rate. And the reason that we use these is there actually are mathematical equations behind this that we could be using that will show us what would be the null hypothesis versus what wouldn't. Think of it in real language terms for a minute. Is statistical significance or not? That's how I like to teach it to my students. I'm kind of a break it down to the basics type of girl, and the truth is it's whether or not you got statistical significance or not. So, what does it mean to be empirical? Relying on or derived from observation or experiment. Empirical results that supported the hypotheses. It's verifiable, provable by means of observation or experiment. This is something really, really important to leave with today. When you write up your methods section, what we expect to see is the people sitting